What is machine learning? Definition, types, applications, and trends for 2024. Machine learning teaches machines to learn from data and improve incrementally without being explicitly programmed. Machine learning, ML, is defined as a discipline of artificial intelligence, AI, that provides machines the ability to automatically learn from data and past experiences to identify patterns and make predictions with minimal human intervention. This article explains the fundamentals of machine learning, its types, and the top 5 applications. It also shares the top 10 machine learning trends in 2024. What is machine learning? Machine learning, ML, is a discipline of artificial intelligence, AI, that provides machines with the ability to automatically learn from data and past experiences while identifying patterns to make predictions with minimal human intervention. Machine learning methods enable computers to operate autonomously without explicit programming. ML applications are fed with new data, and they can independently learn, grow, develop, and adapt. Machine learning derives insightful information from large volumes of data by leveraging algorithms to identify patterns and learn in an iterative process. ML algorithms use computation methods to learn directly from data instead of relying on any predetermined equation that may serve as a model. The performance of ML algorithms adaptively improves with an increase in the number of available samples during the learning processes. For example, deep learning is a subdomain of machine learning that trains computers to imitate natural human traits like learning from examples. It offers better performance parameters than conventional ML algorithms. While machine learning is not a new concept, dating back to World War II when the Enigma machine was used, the ability to apply complex mathematical calculations automatically to growing volumes and varieties of available data is a relatively recent development. Today, with the rise of big data, IoT, and ubiquitous computing, machine learning has become essential for solving problems across numerous areas, such as computational finance, credit scoring, algorithmic trading, computer vision, facial recognition, motion tracking, object detection, computational biology, DNA sequencing, brain tumor detection, drug discovery, automotive, aerospace, and manufacturing, predictive maintenance, natural language processing, voice recognition. How does machine learning work? Machine learning algorithms are molded on a training dataset to create a model. As new input data is introduced to the trained ML algorithm, it uses the developed model to make a prediction. Types of machine learning. 1. Supervised machine learning. This type of ML involves supervision, where machines are trained on labeled datasets and enabled to predict outputs based on the provided training. The labeled dataset specifies that some input and output parameters are already mapped. Hence, the machine is trained with the input and corresponding output. A device is made to predict the outcome using the test dataset in subsequent phases. For example, consider an input dataset of parrot and crow images. Initially, the machine is trained to understand the pictures, including the parrot and crow's color, eyes, shape, and size. Post-training, an input picture of a parrot is provided, and the machine is expected to identify the object and predict the output. The trained machine checks for the various features of the object, such as color, eyes, shape, etc., in the input picture, to make a final prediction. This is the process of object identification in supervised machine learning. The primary objective of the supervised learning technique is to map the input variable, A, with the output variable, b. Supervised machine learning is further classified into two broad categories. Classification. These refer to algorithms that address classification problems where the output variable is categorical, for example, yes or no, true or false, male or female, etc. Real-world applications of this category are evident in spam detection and email filtering. Some known classification algorithms include the random forest algorithm, decision tree algorithm, logistic regression algorithm, and support vector machine algorithm. Regression algorithms handle regression problems where input and output variables have a linear relationship. These are known to predict continuous output variables. Examples include weather prediction, market trend analysis, etc. Popular regression algorithms include the simple linear regression algorithm, multivariate regression algorithm, decision tree algorithm, and lasso regression. 2. Unsupervised machine learning. Unsupervised learning refers to a learning technique that's devoid of supervision. Here, the machine is trained using an unlabeled dataset and is enabled to predict the output without any supervision. An unsupervised learning algorithm aims to group the unsorted dataset based on the input similarities, differences, and patterns. For example, consider an input dataset of images of a fruit-filled container. Here, the images are not known to the machine learning model. When we input the dataset into the ML model, the task of the model is to identify the pattern of objects, such as color, shape, or differences seen in the input images and categorize them. Upon categorization, the machine then predicts the output as it gets tested with a test dataset. Unsupervised machine learning is further classified into two types. Clustering. The clustering technique refers to grouping objects into clusters based on parameters such as similarities or differences between objects. For example, grouping customers by the products they purchase. Some known clustering algorithms include the k-means clustering algorithm, mean shift algorithm, discant algorithm, principal component analysis, and independent component analysis. Association learning refers to identifying typical relations between the variables of a large dataset. It determines the dependency of various data items and maps associated variables. Typical applications include web usage mining and market data analysis. Popular algorithms obeying association rules include the a priori algorithm, eclat algorithm, and FP growth algorithm. 3. Semi-supervised learning. Semi-supervised learning comprises characteristics of both supervised and unsupervised machine learning. It uses the combination of labeled and unlabeled datasets to train its algorithms. Using both types of datasets, semi-supervised learning overcomes the drawbacks of the options mentioned above. Consider an example of a college student. A student learning a concept under a teacher's supervision in college is termed supervised learning. In unsupervised learning, a student self-learns the same concept at home without a teacher's guidance. Meanwhile, a student revising the concept after learning under the direction of a teacher in college is a semi-supervised form of learning. 4. Reinforcement learning. Reinforcement learning is a feedback-based process. Here, the AI component automatically takes stock of its surroundings by the hit and trial method, takes action, learns from experiences, and improves performance. The component is rewarded for each good action and penalized for every wrong move. Thus, the reinforcement learning component aims to maximize the rewards by performing good actions. Unlike supervised learning, reinforcement learning lacks labeled data, and the agents learn via experiences only. Consider video games. Here, the game specifies the environment, and each move of the reinforcement agent defines its state. The agent is entitled to receive feedback via punishment and rewards, thereby affecting the overall game score. The ultimate goal of the agent is to achieve a high score. Reinforcement learning is applied across different fields such as game theory, information theory, and multi-agent systems. Reinforcement learning is further divided into two types of methods or algorithms. Positive reinforcement learning. This refers to adding a reinforcing stimulus after a specific behavior of the agent, which makes it more likely that the behavior may occur again in the future, e.g., adding a reward after a behavior. Negative reinforcement learning. Negative reinforcement learning refers to strengthening a specific behavior that avoids a negative outcome. Top 5 machine learning applications. Industry verticals handling large amounts of data have realized the significance and value of machine learning technology. As machine learning derives insights from data in real time, organizations using it can work efficiently and gain an edge over their competitors. Every industry vertical in this fast-paced digital world benefits immensely from machine learning tech. Here, we look at the top 5 ML application sectors. 1. Healthcare industry. Machine learning is being increasingly adopted in the healthcare industry, credit to wearable devices and sensors such as wearable fitness trackers, smart health watches, etc. All such devices monitor users' health data to assess their health in real time. Moreover, the technology is helping medical practitioners in analyzing trends or flagging events that may help in improved patient diagnoses and treatment. ML algorithms even allow medical experts to predict the lifespan of a patient suffering from a fatal disease with increasing accuracy. Additionally, machine learning is contributing significantly to two areas. Drug discovery. Manufacturing or discovering a new drug is expensive and involves a lengthy process. Machine learning helps speed up the steps involved in such a multi-step process. For example, Pfizer uses IBM's Watson to analyze massive volumes of disparate data for drug discovery. Personalized treatment. Drug manufacturers face the stiff challenge of validating the effectiveness of a specific drug on a large mass of the population. This is because the drug works only on a small group in clinical trials and possibly causes side effects on some subjects.